1.7. Solve absolute value equations and inequalities. An absolute value is a number x that's represented with two bars, and it is the distance from 0 on a number line. The important thing to remember is a distance can never be negative. So you can never have an absolute value that's negative. And those would turn out to be no solution. We'll come across those in a minute. Now, extraneous solution is a solution that is an apparent solution, which means that it seems like it would be true. You've solved the equation correctly and you come up with a solution, but it doesn't check. Okay, interpreting absolute value equations. The equation: absolute value equals the absolute value of x minus 0 equals k. And what does this mean? The distance between x and 0 equals k. Here's a picture of it. Solutions are x minus 0 equals negative k, or x minus 0 equals positive k. So x is either negative k or positive k. These are a little bit weird to understand in just the letters, so let's go ahead and just skip over and leave the rest of that blank. So I need to solve a simple absolute value equation. The absolute value of x minus 3 equals 6. On absolute value equations, I get the absolute value by itself, which it already is in this equation, and then I break it up into two equations. I break it up into the positive side, and then I break it up into the negative side. And I usually do that with a T-chart. So I'll have something like this when I write it on my paper. And then I just solve both equations independently. So x is either 9 or x is negative 3. And what that means is that x is either 9 units away from 0 or negative 3 units away from 0 on a number line. So we're not going to fill out the rest of that either. Okay, solve the equation. Let me go ahead and do this with you since I didn't do much else. So the absolute value of x equals 5. It's a real simple thing, but I'm going to go ahead and show you how I do it. I'm going to put it in my T-chart to say x either equals positive 5 or x equals, I'm going to put the negative on it, negative 5. So I can go ahead and, if I was going to graph this, people usually don't graph these, but this would be how you would graph it. Just here or here. And they like to go ahead and put these little brackety things here to say it's 5 distance. Either way. Next on 2, I'm going to, when I drop the absolute value, put them in my T-chart. x minus 5 equals 2, or x minus 5 equals negative 2. Add 5. So x equals 7, or add 5 again, x equals 3. One of the common mistakes on absolute value is that when a student will get the positive side here, some of them will want to go ahead and just throw a negative sign on it and say x is either positive 7 or negative 7. And that's not really true. You have to go back and solve each side of the equation. Okay, go ahead and skip the bottom part of the first page. Go ahead and go to example 2. We're going to solve this equation. It says to be sure to check for extraneous solutions. So I'm going to draw up the absolute value, and I'm going to have a positive answer, 6x, or a negative answer, negative 6x. Then I'm going to subtract 4x from both sides. To get 10 equals 2x, which we know will be 5 here. Or I'm going to go ahead and subtract 4x from both sides. Get 10 equals negative 10x, and x equals negative 1. Now, I need to make sure they both work. So I'm going to put both answers back in for x and see if they're both true. So the first, I'm going to put my 5 here and my 5 here. So 20 plus 10 is 30. Does the absolute value of 30 equal 6 times 5, or 30? Yes, it checks. Over here, I'm going to put my negative 1 in, and I would have negative 4 plus 10 is positive 6. Does the absolute value of positive 6 equal negative 6? No, this does not check. So positive 6 does not equal negative 6. So the solution is only the 5. We're going to reject the negative 1 because it's an extraneous solution. It doesn't check right. Go ahead and try 3 and 4 checkpoints. Make sure you check for those extraneous solutions. And then start the video again. We're not going to do the box at the bottom. Example 3. Solve the absolute value of 2x plus 5 is less than 3. So this time we have an inequality instead of an equal sign. These are the same to solve, except for one slightly different thing. So let me go ahead and make my t-chart. I have 2x plus 5 is greater than 3. And then 2x plus 5, and this is the different part. When I'm doing an inequality, to give the negative answer, I need to flip that inequality over. So when I put the negative on it, I have to flip it over. Now I just solve each side, just like a regular equation. So I have 2x is greater than negative 2, divided by 2. X is greater than negative 1, or solve my other side, minus 5. 2x is less than negative 8, divide by 2, x is less than negative 4. So to graph this, I would say x is greater than negative 1. Then I find my negative 1, and it's an open circle because it's just greater than. Put color in toward that side. And then x is smaller than negative 4. So I have another open circle, and it's smaller than. Example 4, x minus 1.5 is less than or equal to 4.5. When I drop those absolute value, I'm going to have x minus 1.5 is less than or equal to 4.5, or x minus 1.5, flip it, negative 4.5. I'm going to add 1.5 to both sides. X is smaller than or equal to, that's 6, or add 1.5. X is greater than or equal to, that's negative 3. So to graph it, find my 6, and it is closed dot because it's less than or equal to. And color it this way. And then x is also greater than or equal to negative 3. So I color it this way. And that would be my solution. So checkpoints, solve inequality, then graph the solutions.